only one unit of GPU for numerous users or on CUDA applications by using MIG. However, it is suitable for data scientist model developing tasks or inference tasks and not for large-scale tasks like distributed training. And it allows more efficient use of GPU resources if utilized well. Then, let's move on to the second case study. I'd like to introduce POC related to GPU-direct RDMA technology. As the size of the model gets bigger and the amount of the data is increased to enhance the accuracy of deep learning, we need countless computers and efficient distributed processing. I'm going to explain GPU-direct RDMA technology for multi-node GPU distributed training and system architecture, as well as some examples, and share the performance verification result. First of all, GPU direct RDMA is a function that allows direct access to GPU memory between GPU communication between remote nodes, and through the network interface, data I/O between GPU memories is processed without involving CPU. To understand it better, let's take a look at 4 cases. The 2 diagrams at the top show the different GPUs communicating within a single node, and the other 2 at the bottom shows the communication between GPUs of the remote node. First, let's take a look at the communication of GPU within a single node. Without GPU direct peer-to-peer, the host CPU must transfer the data from the GPU memory to the host memory, and then from the host memory to the other second GPU's memory. But with GPU direct peer-to-peer, the data can be transferred directly from GPU memory to the other GPU's memory. It works similarly for internode communication as well. Without GPU direct RDMA, then the data must be copied from the GPU memory to the host memory, and then from the host memory to a remote host. But with GPU direct RDMA, the data is transferred directly from the GPU memory. It is sent via RDMA network adapter like InfiniBand to the remote host with no CPU involvement. It seems that the communication will be done more quickly without CPU involvement. So, then what do we need to use GPU direct RDMA? Various environment setting is necessary for GPU direct RDMA, applying GPU direct RDMA to Kubeflow. For hardware, we need network equipment that supports RDMA communication. And for our POC, we've set bare metal environment with InfiniBand network adapter and NVIDIA A100 GPU. In order to detect GPU and network adapter, driver and turkey setting is necessary for operating system layer and Kubernetes system layer. The parts in light green are the modules for using GPU, and those in dark blue are the modules for using a network adapter. Let's first look at OS layer. We have to set 4 things displayed in the diagram. When NVIDIA developer is installed to have GPU recognized and OS, and the NVIDIA Container Toolkit is set to be run on Kubernetes, then it is possible to use GPU. After installing all-fade driver to have InfiniBand network adapter recognized and installing MVPMM driver that supports RDMA communication, then setting of OS layer is completed. When the setting for OS layer is done, then let's take a look at Kubernetes layer. As you can see, we have to set NVIDIA device plugin and RDMA shared device to Kubernetes layer. NVIDIA device plugin is a demo set that automatically recognizes and runs GPU in Kubernetes layer. It is mandatory for using GPU in Kubernetes. If RDMA shares a device that allows access between pods by sharing the RDMA device between the remote Kubernetes nodes, then we are ready to use GPU direct RDMA in Kubernetes layer. The part in yellow is the container image layer, and we used CUDA, CUDNN, and NICU for our POC. Then all the preparation is completed to use GPU direct RDMA. Let's take a look at the sample that we tested. It is a YAML that executes distributed training on image segmentation model using training operator PyTorch job embedded in Kubeflow. We set the part in red rectangle to use GPU direct RDMA. First, setting of two OS environment variables in container image is necessary. One variable is for NICU communication using InfiniBand, and the other is for GPU direct RDMA level. Then, after we designate RDMA shared device, which is the custom resource set in Kubernetes layer in advance, then set the security contact for IP lab. Then we can proceed with the task we want. Let's look at the log that has actually been executed. The OS environment variable is set is set properly, and we can see the A100 GPU. And InfiniBand is set to 0. This means that Infinity is not disabled. In other words, we use InfiniBand. Using GPU direct RDMA, we can see a NICU log where training takes place. How effective would it be? Then let's see. This is throughput measured by increasing the number of GPUs for image classification, detection, and segmentation model, and natural language understanding model in our POC environment. We increased the number of GPU from 1 to 2 for 8, 6, and 16, and used a total of 16 GPUs for the red rectangle. And it is the comparison of performance results between the green bar that uses GPU direct RDMA and the blue bar that does not. It differs model by model, but generally we can expect the impact to be around 114 to 612%. Basically, as the number of GPU increases, the performance improves. But in some model, the performance of multi-nodes may be undermined if a huge value of parameter communication continuously takes place in the model. But by using GPU direct RDMA, it can communicate more effectively. As we saw the performance verification result, we achieved extremely satisfying the result, and by applying this, we released InfiniBand-based multi-node GPU service on SSP last month. And yes, yes, that's it. I think this is all I wanted to share today. The presentation was based on the cases from our experience, and although it was a brief explanation completed in about 30 minutes due to the time limit, but I want to mention that we have gone through a countless trial and error. Many of you working in this field may be or will be going through the same difficulties, so I hope you find my presentation a little bit helpful. And I'd like to finish today's presentation, so thank you for your time and attention, and stay and have a safe trip, and thank you. Thank you. And also you can download this presentation at the schedule.com. And any question?
I have one.
Okay.
So I noticed you use Docker for your engine over Kubernetes rather than container group.
Yes, actually we proceeded with the POC based on Docker, but basically our Kubernetes service is based on containerd, so we basically processed with the containerd base too.
Okay, one of your slides noted that you use Docker.
Yes, it is based on Docker
You
wizard.
did the test with containerd?
Oh yes.
Okay,
And
thank you.
In one of your first slides, it looked like you were having trouble on Kubeflow recognizing the MIGs. And then you mentioned that you had to apply changes, but I wasn't clear if the changes in the YAML file were only applied to the Samsung SCP service, or if it was something that got committed back to Kubeflow.
absolutely. Could you take off your mask and please speak again?
Earlier, you had trouble having Kubeflow recognize your MIGs, your GPU MIGs. You mentioned that you had to apply changes to some YAML files so that Kubeflow could see your MIGs. But I wasn't sure if it wasn't clear if those changes were applied to the Samsung SCP platform or if they were committed back to Kubeflow.
Actually, we applied it to our SSP Kubeflow service.
Okay. So does that mean then that Kubeflow may still have trouble
Oh, yes,
identifying images? Thank you.
Any other questions?
When you were doing your distributed testing with MIG, right, and you're using MIG instances to run distributed with single MIG instance in each container, what was the interconnect? Was it just using Ethernet as the interconnect because of the lack of GPU direct when you're using MIG?
I'm sorry. Could you take off your mask, please? I'm sorry.
One of the first tests you were running was distributed training in MIG, right? You did it with 2 MIG instances per container and it failed, but with a single MIG instance per container, it worked. What was the interconnect?
Actually, it is the NVIDIA. It is based on NVIDIA architecture, so they designed with
So I'm guessing it wasn't using InfiniBand, it was falling back to Ethernet in those cases?
Ethernet or Ethernet. You mean?
Interconnect, like for the distributed communications.
It is with InfiniBand.
It was using InfiniBand with a single MIG instance?
No, actually, InfiniBand is for the remote nodes in internet. So internet doesn't need any InfiniBand network adapter. It is communicated within the in the single node. So that does not need any infinite bandwidth in a single node.